Hello everybody, welcome to the Go language course. In this video, I'm going to discuss the use of type conversions in Go language. Before I do the discussion, I have to include the main package on the first line of the program, and I also have to include the FMT package that will be able to help me use the printline function coming from this package, okay? And let us go to the main function first. What is type conversion in Go language? Actually, Go language supports explicit type conversion, so I can just do the conversion of the type very easily by using some of the built-in functions. So for example, I want to convert some integers. So I can convert int here to int64, and I can also convert an integer to an int32 type, okay? So let us see this result by printing all these a, b, and c variables, which will be of different data types. Okay, you can see 3 sevens coming out. Because they have turned to integers, they can all be printed out. Okay, so we cannot see the effect of the integer type conversion here because all these integer data types would just print out 7. Okay, but it is still possible for me to do this kind of type conversion to change int to int64 or to int32. Okay. In addition to integers, I can also do the floating point number conversions. So let us see this example. Now I have a float 64 number, and I can convert it to a float 32 number by using the float 32 function, okay? And of course I have to denote the new variable called e with the correct type called float 32. So let me print out the result of these 2 variables, one of float 64 type and the other one for float 32 type. Yes, you can see that I have 3.14 for 2 times, but these 2 variables would have 2 different data types already, okay? Now, let us talk about the conversion between an integer and a float value. So I can use the float64 function to do the conversion so that if f is an integer, it can be converted to a float64 number. And I can also do the reverse conversion from float64 to integer by using the int function here, okay? And here we can see that I can turn g here to h. And I can show the values of fgh after the type conversion between the integer and float. Okay, you can see that we have 3 31s here, but each of the 31s here would be of different data type. F is for int, G is for float64, and H is for int again, okay? So this H is coming from a float number, which is of float64 type, okay? Okay, we can also do the conversion between an integer and a string. So let us talk about the first direction, which is integer to string. So suppose I have I1 here, which is an integer, and I can turn it to a string by using the strconv package, which means string conversion. And in this package, I have a function called I to A. I here means integer and A means ASCII code. It means that I'm going to turn an integer to a string by using this one. So when I use this package called strconv, the import statement here is already adding the same package name for me directly. And when I do the conversion in this way, from an integer to a string, I'm able to store the string result to another variable of string type here, okay? So let me see the result of printing this S1 here. Yes, you can see 42 here. Notice that 42 has the string type rather than the integer type here. But of course, when we do the printing, it is not easy to see the data type of it. That's why we have to make sure that we understand the particular variable type that we are using, okay? Here, let us do the conversion from a string to an integer. So suppose I have a string here called 42, and you have to notice that I have to include a pair of double quotation marks to surround the number. And let me set up a variable called I2, which is of integer type. And here I have to also set up an error variable called ERR1, which is of error type. Why is it necessary to use the error type here? Because for the conversion from a string to integer, it doesn't always work if the string contains non-numerical characters. So we have to notice that it is possible to have errors during this conversion. So here I have to use A to I, ASCII to integer, to help me do the conversion from a string to an integer. Of course, this function is coming from the strconv package again, okay? So I2 is the integer that will show up if the conversion is really successful, and ERR1 here is the error message that will come up from the A to I function if the conversion fails. So I have to say something here. If the error isn't equal to nil, that means we have some error. I just print out the error message that is returned by the A to I function. If there is no error message, I just print out the value directly. So let us see the way of running this part of the program. So now I can do the conversion correctly because 42 here is having numeric characters only. So I don't have any error during this conversion from ASCII code to integer. So let us see the situation if it is having some problem with the conversion process. Suppose I add A here so that you will be able to see that I'm not able to do the conversion because of this non-numeric character. So you can see that I have an error coming out. It says that it is not able to parse the meaning of 42A here. Okay, because A isn't able to be converted to a number because A is not really a number. Okay. In this case, I will just go to the first branch of the if statement here, okay, to show the error message. Now, let us talk about the conversion between a float number and a string. So, we already saw that integers can be converted to a string. And how about a float number? It is possible to do so as well. So, I have a float number here of float 64 type. In order to do the conversion, I have to use the FormatFloat function coming from the string conversion package again, okay? So the FormatFloat function is something like this. We have a number of parameters. The first parameter is the number to be put into the function, and then I have to say the format of the conversion. If I want to just convert to an ordinary float number, I have to include F character here. So F here is a character surrounded by a pair of single quotation marks, okay? And F here is meaning this format. We have no exponent and we have just digits followed by a decimal point followed by other digits, okay? And here PREC means precision. It means the number of decimal places for my conversion. So I want to have 2 decimal places in my answer of the conversion. So I say 2 here. And the bit size here is meaning the number of bits for your number to do the conversion. So I have 64 bits here. Okay. And of course this function would return a string. That's why I will have this function call here to help me change 3.14, which is a floating point number, to a string. Okay. Let me see the result of running this part of the code. So I will see 3.14 here, and 3.14 is now a string, but not a floating point number any longer. Okay. And we can also do the conversion from a string to a float number. So I have a string here, 3.14 here are all numerical characters. So this decimal point here is also able to be interpreted as a floating point number. Okay. So I have to include these characters with a pair of double quotation marks to denote a string. And then I have a variable called f2, which is of float 64 type. And I have an error variable here called ERR2, which is of error type. So the meaning of having an error is that it is sometimes possible to have mistakes or errors coming from the conversion. So we have to just obtain the error message coming from the conversion if this conversion fails. So the idea is to use the ParseFloat function coming from the string conversion package again. So I pass the string here, and I want to denote the number of bits to return for my conversion. And this function would have a tuple that contains two values. And the first value of the tuple is of float64 type, and the other content for the tuple is of error type. So if it is possible to do the conversion, the value will be stored in the first variable. Otherwise, I would have the error message stored in the second variable. Okay, so if the error is not nil, that means the error has occurred. I would just print the error message. Else, I just print out the value that is converted after this conversion. So let us see the result. Yes, I can do the conversion. So 3.14 here is now a floating point number rather than a string. Okay, so how about if it is not able to do the conversion from a string to a float number? Let us see this example. Suppose I have a y in the string, and of course y is not a numeric character. That means it is impossible for me to do the conversion from a string to a float number. So let us see the result of this code. You will see error coming out because y is not able to be turned to a number. Okay, it means that I will go to the first branch of the if statement here. Okay, now let us see the conversion between a string and a byte slice. Why is it necessary to do this kind of conversion? Let us see the reason. Strings are really immutable. The byte slices are mutable. That means when we have set up a string, it is not able to change the content of it any longer. But for byte slices, we can still change the content of it after it has been created. That's why we have the advantage of converting the content of a byte slice. And we can do the conversion from a string to a byte slice in the following approach. So the byte slice would be trying to store the ASCII code or the Unicode of your data. So suppose I have S5 string here, and I turn it to byte slice by using a pair of square brackets followed by the byte keyword followed by the string here. Okay, so after that I'm able to do the conversion. So let us see the result. Okay, you can see that the byte slice here is something like this. I have 6 characters, and I'm able to show all the 6 ASCII codes of the characters. Okay, so I'm able to turn a string to a byte slice, and from this byte slice, I'm able to change the ASCII code so that the letters can be turned to another one by means of this byte slice content change. Okay. Here we can do the conversion from a byte slice to a string. So I've got the byte slice already, and I can use the string keyword to turn it to a string. So let's see the result of running this part of the code. Yes, you can see that the byte slice can be converted back to a string. So we can make a byte slice and do the conversion in the byte slice, and then we can turn it to a string again. So in this way, we can mutate the content of a string by using this conversion. Okay. Finally, let us talk about custom type conversion. What is the meaning of the custom type conversion? Let us see this example. I've made my new type called SumFloat before I go to the main function. So before the main function, I already made my user-defined new type called SumFloat, which is of float64 type. And here I can use the SumFloat type as the custom type. And you can see that I can use SumFloat here to become my custom type, which represents the float64 type here. So now I have 8.41 here. And I can convert the SumFloat type to float64 type, even though it is already a float64 type. That means I'm able to change the data type to another one. And I can use the float64 function here to handle my value here, and my value of some float type would be converted to the float64 type again. Okay, so when I print the my value float here, I'm able to print it out because this conversion is really successful. And on the other hand, we can do the conversion from an integer to some float instead. So I have a variable called my value some float, which is of some float type, which is this new type here. And I can do the some float type conversion to allow my value float here to turn to some float type. And of course, this conversion will be successful so that I'm able to print it out. Okay, I mean I print the my value some float variable out. So let us see the result. Okay, you can see that I am able to print out 2 lines here. Both are showing 8.41, and 8.41 for the first value would be the float64 type, and the second value printed out here would be of some float type, which is my new type created before the main function. Okay. So this video has discussed many ways of doing the type conversion. It mainly relies on the built-in functions from the Go language together with the functions from the string conversion package. Okay, by using the string conversion package, I'm able to do the integer to string conversion, the string to integer conversion, and I can do the conversion of integers to other integer data types, and I can also do the floating point number conversion. I can also do the conversion between a float and a string by using the FormatFloat function coming from the string conversion package. I'm also able to do the conversion from a string to a float number by using the ParseFloat function from the string conversion package again. And I can turn a string to the corresponding byte slice so that I can mutate the content of the byte slice, which can be converted back to a string. Finally, I'm able to do the custom type conversion by converting between a built-in type to my new type that is defined by me. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.